At the heart of nearly every machine that moves our world is a powerful, elegant piece of engineering, the induction motor. But how does this incredible device actually work, and how is it built? Let's dive into the fascinating world of motor manufacturing. It all starts with the principles of electromagnetism. A stepper motor, a simpler cousin of the induction motor, shows us the basics. By energizing electromagnets in a specific sequence, A, B, C, then D, we create a rotating magnetic field. This field attracts the permanent magnets on the rotor, causing it to turn one precise step at a time. This is the fundamental magic that makes all electric motors spin. A three-phase induction motor uses this same principle but on a much larger scale. It has three main sets of windings, or coils, labeled U, V, and W. When connected to a three-phase power supply, these coils create that all-important rotating magnetic field. The way these coils are connected, either in a star or delta configuration, determines the motor's operating characteristics, making it suitable for different power requirements. Now, let's see how these giants are born. The process begins with the heart of the motor, the stator core. This is a stack of thin, insulated metal plates. Skilled workers meticulously insert pre-wound coils of beautiful, enamel-coated copper wire into the slots of the stator. This is a precise and labor-intensive process, as each coil must be perfectly placed and shaped to create a balanced and efficient magnetic field. Every single wire plays a critical role in the motor's final performance. Once all the windings are in place, the rotor, a solid cylindrical core, is carefully inserted. The end bells are then attached, bearings are greased, and the entire assembly is bolted together with immense force. After a fresh coat of paint, the motor is complete. From simple electromagnetic principles to a marvel of industrial engineering, this is the satisfying process of building the powerhouse that drives our world.